Hello, good morning, and welcome to Irish Manufacturing Research's first webinar of 2024. This morning, we are joined by Diana Vaz, who is a Renewable Research Technologist here at IMR, and she will be presenting on the role of renewable energy systems in the decarbonisation of industry as she unravels the transformative impact of renewable energy systems on manufacturing. Her background in renewable energy engineering and sustainability drives companies towards effective decarbonisation. With prior experience as a consultant, her strong commitment to sustainability is evident through her deep expertise in renewable energy, energy efficiency, and decarbonisation strategies, as well as carbon footprint calculation. Diana is deeply passionate about guiding companies in their transition towards sustainable practices, aiming to leave a positive imprint on both the economy and society. Her academic foundation includes a bachelor's degree and an M.Eng in mechanical engineering with a focus on energy and environment, and a postgraduate diploma in circular economy. If you have any questions throughout the webinar, please use either the chat function that you've been putting in your chats to, or the Q&A function, which is on the bottom of your screen, and we'll have time to get to them at the end. So, with all that said, welcoming our presenter. Good morning, Diana. Take it away.
Thank you very much, Gary. Hello, everyone. Welcome, and thank you for joining us in this webinar. Without further delay, I'm going to start. This webinar is on the role of renewable energy systems in the decarbonization of industry. We are going to start with a very quick introduction on the importance of renewable energy systems and on the importance of energy transition for industry in Ireland. Then the primary part of our webinar will be focused on an overview of renewable energy technologies. Specifically, we are going to address the ones that you can see on the screen. Finally, I will make a very quick presentation of the renewable energy feasibility assessment service that IMR offers. And finally, as Gary said, we are going to have some time for Q&A at the end. So let's start by understanding why are we talking here today about renewable energy systems? Well, renewable energy systems are a key aspect for energy transition. And why is energy transition important for industry? Well, we can see in this graph the CO2 emissions related with the energy usage on industry in Ireland throughout about 20 years. And even though it's perceptible that there has been a slight decrease, as per 2022, the last year of this graph, Ireland's industry energy-related CO2 emissions corresponded to 10% of the total emissions of the country. So 10% is the decarbonization potential of industry if they tackle energy-related emissions alone. Environmental sustainability is a huge driver for industry's energy transition, but there's more to it than just environmental sustainability. Energy transition is also about security and access of a fundamental resource, energy, for businesses' operation. And it is also about economic growth and development, and about ensuring competitiveness of businesses. So let's now dive into the different renewable energy systems. But to start, I'm going to ask, what is renewable energy? Well, renewable energy is energy that comes from natural resources that have higher replenishment rates than consumption rates. Examples of renewable energy sources are the sun, is the wind energy, is the earth itself with geothermal energy, just to name a few. And of course, it is necessary to have technology that allow us to harness these types of energy in their raw form and convert it into a useful form of energy for our homes, our businesses. And those types of useful energy are, well, for example, electricity and thermal energy, heat. There is a wide variety of renewable energy technologies available in the market, all of them with their advantages and disadvantages. Today, we are going to focus on these 8 types and groups of technologies, namely solar PV, wind turbines, battery energy storage systems, heat pumps, geothermal-related systems, CHP systems, or combined heat and power systems, and biomass and hydrogen-related applications. So let's start with solar PV. First, PV stands for photovoltaics. Photovoltaics is a word that is formed by two other words. Photo, that is the Greek word for light, and volt, which is the unit of electric potential. And the name itself already gives away what is the function of a photovoltaic panel. So photovoltaic panels convert directly sunlight, and it's important, it's the light, not the heat, into electricity. There are other types of solar technology available, and even other types of solar panels. For example, the panels that convert heat from the sun into hot water. However, when we are talking about a technology that generates electricity through the sun, we are talking about photovoltaics, even though we commonly refer to it just as solar technology. Solar PV is one of the most popular technology types and renewable energy technology types in the world right now. And there is a very good reason for it. Photovoltaics rely on a source of energy that is free, that is abundant, and that is everywhere. Additionally, the technology is modular, which grants a huge flexibility at the time of implementation. The technology prices are very competitive nowadays. It is easy to navigate the planning permission process, and sometimes it is not necessary to have a permission for the deployment of the project. During the operation period, they are silent, PV panels are silent, and their operation is also clean. Furthermore, they do not require a lot of maintenance, which means there is not a huge maintenance cost associated with the installation of PV panels. There's, of course, some downsides to this type of technology. They do require some space, and it is not possible to control the production output of PV panels. PV panels produce energy when the sun is shining, and the sun shines when the sun shines. We all know that Ireland is better renowned by its wind and waves rather than by its sunshine. However, falling costs of PV have made it an appealing solution for Ireland's electricity generation. You can also see in the map that shows the potential of solar energy, solar PV energy across some countries of Europe and North of Africa. And we can see that, of course, the potential for solar PV is much lower in Ireland than in other countries, but that doesn't mean that we cannot leverage this kind of energy source. It's important to note that Ireland's use of solar energy is considerably lower than the one of European countries at roughly the same latitude. However, the deployment of solar energy in Ireland has been increasing for the past years, and it is expected to increase even more in the next years. In fact, solar PV is now a strategic technology for the decarbonisation of Ireland, and it has a target of, there's a target of 8 gigawatts of solar power to be installed by 2030 as per the Climate Action Plan of 2023. But let's understand a little bit more what is the PV potential in Ireland. We can see it in this map that is the same as before, but we are looking closer into Ireland. And according to this map, the PV potential in Ireland is, well, for 1 kilowatt peak installed, we can expect an average of 1,000 kilowatt hour of electricity per year. To make this a little bit more relatable, 1 kilowatt peak corresponds to roughly 2 panels. It really depends on the type of panel, but in average terms, 2 panels. And 1,000 kilowatt hour corresponds to 22% of the average consumption of a house. So this is the potential of solar PV in Ireland. As said before, the PV technology is very flexible in terms of implementation. These are some of the possible mounting systems for solar PV. It can be installed on rooftops. This is one of the most popular configurations. It can be installed in the form of car canopies. It can be ground mounted, and it can even be integrated into buildings. When designing a PV system, it is important to have several aspects into consideration. Usually the one that, well, sets the rhythm for the design project is the available space that is going to condition the amount of the size of the system. It is also important to have into account other aspects, such as the energy consumption profile. PV panels obviously are more interesting for applications in which the energy consumption occurs during the day when we have sunlight. It is also very important to have into account the structural resistance of the rooftop, if that's the intended space for the application of PV panels. And other aspects such as the location, the shadows from surrounding elements such as trees, chimneys, and other buildings, orientation, slope, and capacity of the panel, grid connection issues. For example, if the grid has the capacity to absorb the excess energy that will be generated, if that is the strategy selected to deal with surplus energy, and it is necessary to check if there is planning permission requirements. Now, the second type of technology that we are going to talk about today are wind turbines. Wind turbines harness the kinetic energy of moving air and convert it into electricity. Wind is also a free, abundant, and inexhaustible resource, so the operation costs of wind turbines are also very low, although they do require some more maintenance in comparison with the PV systems. They also share with the solar PV systems the disadvantage of having an uncontrollable production output. Wind turbine energy output depends on wind speed, and that's something that we cannot control. It has more deployment constraints, mostly in terms of planning permission than solar PV. We will get into that with more detail in the next slide. And usually it is economically feasible when we are considering high installed capacities, and when the wind turbines are meant to supply sites with high energy demands. Ireland has a huge wind potential. We can see that in the map. We are in a very privileged location in terms of availability of this kind of resource. And this is even more accentuated for offshore applications, as we can see in this map. So, of course, wind is a very strategic technology for Ireland, and it is also contemplated in the Climate Action Plan with very specific targets. When considering a wind turbine system, there are also several aspects to have into account. Wind resource is one of the most important ones. There is two main factors that affect the production output of a wind turbine. The characteristics of the wind turbine itself, such as the height and so on, and the wind resource, the wind speed that is available at each given time. So to know the wind resource, the site elevation has to be assessed. We also have to assess the topography of the terrain, and we have to take into account the characteristics of the surrounding area. Another aspect that plays a very important part in the design of wind turbine projects are the constraints related with the planning permission. National and local regulation and legislation have to be consulted to make sure that the site in which the deployment of wind turbines is intended is not out of reach due to environmental constraints, due to archaeological or architectural heritage constraints. due to constraints related with proximity to existing land use, and due to constraints related with landscape and visual impact. For example, in this image, we can see a map that shows protected areas, well, the designated areas by the National Parks and Wildlife Service of Ireland. And these are some examples of areas that in which we cannot install wind turbines. And finally, of course, it is necessary to assess if the place where the installation of the wind turbine is intended is reachable, and if the parts of the wind turbine can be transported to there. So far, we have talked about two types of technology that produce electricity from renewable sources and that are very weather dependent. What happens when we have these kind of technologies is that sometimes we are going to have periods in which there is energy demand, but we do not have enough energy production from those energy systems. While during other periods of the day, we are going to have a production output that is superior to the energy that is required. You can see an example in the screen of a daily profile, of an hourly profile across a day of PV production and of the demand of a site. So the deployment of renewable energy sources requires mechanisms to help balance production and demand. There are several strategies to help to balance, to help to reach that balance, and the incorporation of energy storage systems is one of them. There are many types of energy storage systems. The one that we are talking about here today in particular are batteries. Batteries fall within a very specific category within energy storage systems. They correspond to electrochemical storage. They are very useful mechanisms to help to balance demand and production. However, they also have other types of applications. They can be used for to ensure energy autonomy in off-grid systems. They can also be used to offer arbitrage systems to arbitrage services to a site, among other. This is a kind of technology that is modular, which allows for a flexible system. And even though there is not necessarily a cost of operation associated with the batteries, they do require periodic inspections and maintenance by trained personnel, and that, of course, comes with a cost. There are several types of batteries, mature technology types of batteries commercially available. These 5 that I'm showing you on the screen are examples of that. From these 5 types of technology types, there's one of them that stands out, lithium-ion batteries. This is the primary technology for battery storage at the commercial level. You can see in the graph that lithium-ion batteries dominated the market, the battery energy storage market, in a matter of years, and they are still expected to be the dominant technology in the market in the short and medium term, meaning up to 2030, along with full batteries that are more suitable for large-scale applications. Nevertheless, there are battery technologies that are emerging nowadays that are expected to play an important role in the market in the long term. I mean, towards the end of 2040 and 2050. When selecting the type and the size of a battery energy storage system, there are several aspects to have into account, such as the intended service and application for the battery system. It is very different to design a system for an off-grid application or for an arbitrage service. The land usage optimization is usually a factor that conditions the design of the system. Granting optimization of the land usage implies lower capital costs. So this is usually one of the most relevant factors when planning this type of technology. Of course, the battery type also plays an important role. Different battery technologies have different characteristics, and that's something that has to be taken into account when analyzing a possible technology to deploy on a site. Namely, they have different round-trip efficiencies that can affect the output of the system, and they also have different energy densities, which can be determinant depending on space constraints or not. And of course, there's also the need to select the type of location or type of deployment of the battery energy storage system. They can be deployed indoors or on an open rooftop, which comes with more limitations in terms of space. They can be deployed outdoors, which requires a higher maintenance, or they can be deployed on what we call an industrial indoor setting. Now let's enter into the heat pumps section. With heat pumps, we also start to tackle the type of technologies that deliver thermal energy. So heat pumps are thermal machines that are electricity powered. However, they have very high efficiency rates. One of the biggest advantages of heat pumps is that they promote electrification, and electrification of heat is strategic for decarbonization. So they boost the transition from fossil fuels to clean energy. However, it is very important to have into account that a system that incorporates a heat pump is only fully renewable if the electricity that is being provided to the heat pump to operate is also renewable. So it is usually recommended the installation of a heat pump or a system with heat pumps along with a system that generates renewable electricity, such as a PV system. This also helps to mitigate the spark gap effects. Its spark gap effect is related with the fact that gas prices are usually much lower than electricity prices. And so the economical advantage of installing a heat pump will at the end depend on the coefficient of performance of that heat pump. So heat pumps are highly efficient. Their coefficient of performance depends on the type of heat pump, but they can be up to 5 times more efficient than, for example, boilers. They have limitations when it comes to high temperature applications, and as we said, they also have the disadvantage of consuming electricity. Now, there are several types of heat pumps, as I said. They are usually categorized according with the heat source. What is that? A heat pump delivers thermal energy by leveraging the temperature differential between the operating fluid of the heat pump and the heat source. And the heat source can be air, water, or the ground. So here we can see the different types of heat pumps. Air source heat pumps are one of the most common types of heat pumps. It's the kind of heat pump that we can have at our own home. They are very popular because they have a very straightforward installation, design process, and maintenance. They are very cheap, and the maintenance costs are also very low. However, they also offer a lower efficiency when compared with the other types of heat pumps. Water source heat pumps, on the other hand, are more expensive, but they also have higher efficiencies. However, they require planning permission, and they are very dependent on the local availability of a water body that can be used as the heat source. Ground source heat pumps share some of the characteristics with the water source heat pumps. This is the type of heat pump that has higher costs, specifically in terms of initial investments, and they are particularly recommended for greenfield applications, not so much for brownfield applications. It shall be said that within each type of heat pump that I'm presenting here, there are different types of, well, heat pumps, different type of technologies, or different types of configurations. I'm going to talk very quickly about geothermal. This is not a type of technology that may be interesting for most of you. Geothermal energy utilizes the accessible thermal energy of the Earth's interior. We can divide it into two main groups: the shallow geothermal applications that consist on ground source heat pumps that we have just seen, and deep geothermal that requires drilling into large depths. Deep geothermal energy has the advantage of being reliable. It can be used for large and small scale applications. The industry is expanding, and usually that means that the prices of the technology decrease, and the infrastructure has longevity. However, it is very location dependent, and it comes with a very high initial cost and at the same time with a very high risk. So more than 50% of the cost of a deep geothermal project is on the stage of drilling and testing. This is one of the first stages of the project. And during that stage, well, the ground on the place of the project is drilled, and it is assessed if the location is suitable or not for that kind of project. So the larger amount of money of the project goes into this stage, and the conclusion of this stage can be that the project is not feasible, technically feasible on that stage. And that is one of the reasons why geothermal, deep geothermal applications are not widely seen here in Ireland. Now let's move into combined heat and power systems, or CHP systems. So CHP systems generate electricity and useful heat at the same time. And useful heat is highlighted for a reason. So traditional electricity production systems all work, well, there are several types of systems, but in a nutshell, they have a similar operation principle. Usually they imply the combustion of some kind of fuel to generate thermal energy. That thermal energy is then converted into mechanical energy or motion, and that motion is then converted into electricity through a generator. The heat that goes into that process, however, is not all used. I mean, the heat that is generated at the beginning of the process is not all used in the electricity production. A considerable part of that heat is often wasted. What CHP systems do is to utilize that heat that otherwise will be wasted. There are several types of CHP technologies. We are going to look into them on the next slide. It is important to note that a CHP system can be considered a renewable energy system if it relies on renewable fuel or on a renewable source of heat, such as geothermal or solar thermal systems. Some systems also use waste heat from industrial processes, and that helps to increase the efficiency of the original energy system, and at the same time it helps to mitigate or to avoid emissions that would come from the consumption of electricity from another source. CHP the environmental impacts of CHP then depend on the type of fuel that is used. These systems have the disadvantage in comparison with the others that we have seen before of having a high operation costs due to the price of fuel. Fuel, unlike sun and wind, is not free, so there's this cost associated with the operation of the system, but has the advantage of being much more flexible in terms of energy output. The final flexibility that the system has depends on the type of system. Now, when selecting the technology type for a CHP system, it is important to have into account the heat and power demand, because that will determine the system capacity, and the system capacity can determine the type of system. It is also important to have into account that usually a CHP system is only economically feasible for applications in which the heat and power demand are consistent throughout the year. The great heat that is necessary is also a consideration to have into account when selecting the system, and also the type of fuel. It is crucial that a company that is considering a CHP system for their settings to make sure that the fuel that CHP system is going to use has a secure supply chain. Now we can see here the diverse types of CHP technologies. We have internal combustion engines, combined or open cycle gas turbines, steam turbines, ORC or organic Rankine cycle turbines, Stirling engines, and fuel cells. If we are looking for a CHP system for an application that requires a lower capacity, we can see on the last column with the Scholar scheme that we can select, for example, can go for a Stirling engine or a fuel cell. For higher capacities, there are other technologies such as internal combustion engines or steam turbines. And if we require a very high installed capacity, the most suitable technologies are combined or open cycle gas turbines. If you remember, I explained before the basic operation principle of electricity systems, and I said that most of CHP systems or technologies work based on the same principle. There is an exception, though, in this table. Those are the fuel cells. Fuel cells, unlike the engines or the turbines, do not require the combustion or the use of a thermal energy source to operate. Fuel cells, they produce electricity and heat based on electrochemical reactions. As said before, the environmental impact or the environmental impact avoidance of a CHP system depends on the type of fuel that is used. Some of the technologies can use traditional fuels like biodiesel or natural gas, but most of them are already prepared or are have solutions being developed to operate with low or zero carbon fuels or heat sources. We are talking about fuels or heat sources such as hydrogen, please have into account that hydrogen can only be considered low or zero carbon if we are talking about blue or green hydrogen. And we also have biomass-based fuels, biofuels or biogas. And with that, let's enter into the section about biomass. Well, bioenergy is produced from a variety of organic materials called biomass. The environmental benefits of using biomass depend on the type and on the source of that biomass. And we'll see that a little bit later in the next slide. Biomass can be used in several applications. It can be directly combusted and used to provide thermal energy for space or water heating, or even for industrial processes. or can be used as a fuel for CHP systems like we saw before. CHP biomass-related technologies have the advantage of usually being very reliable and having a very flexible energy output. They, of course, have high operation costs because that biomass needs to be purchased. It requires space to deploy the systems, and biomass usage can either promote waste reduction or have some adverse environmental impact, and that depends on the biomass source. First, we have to take into account that sustainable biomass for energy should only be from those sources with low risk of competing against alternative uses, both food and non-food. This is according with circular economy principles. So there are two types of, we can separate biofuels into two types of biofuels according with the source of the product that is used to generate them. We have first generation biofuels that are produced from crops that are directly from the fields and are generally edible. And we have second generation biofuels that are produced from residual and waste products. Our recommendation is that biofuels, technologies that are based on biofuels should have biofuels that comes from second generation products. This also means that biomass-based technologies are mostly suitable for businesses or activities that have those kind of products as a byproduct of their activity. Because biomass or biofuels can be purchased or they can be produced on site. So we have three main categories of biofuels. We have solid biofuels, liquid and gaseous biofuels. In the category of solid biofuels, we have wood chips, wood pellets, and other kinds of pellets. Wood chips are produced with a process called wood chipping, and pellets are produced with a process called pelletization. I am only showing the last column shows the sources, the products that can be used to produce that biofuel, but I am only showing the second generation sources. First generation sources are not recommended by us, and thus we are not displaying them in this presentation. So wood chipping can come from waste wood. Wood pellets can also come from waste wood. And other kinds of pellets can be generated by agricultural slurry, municipal sewage, and sugar beet pulp, for example. Within liquid biofuels, we have fatty acid methyl ester, or FAME. This is also known as biodiesel. We have hydrogenated vegetable oil, and we have bioethanol. We won't show the source for bioethanol because there are only first generation sources to generate it. However, the other two kinds of liquid biofuels, biodiesel and HVO, can be produced from tallow and waste animal fat or from waste cooking oil. Finally, we have biogas within the gaseous category of biofuels that is produced through anaerobic digestion and can be produced using also agricultural slurry, sewage, and other organic matter. Just so that you can have that information, biogas can also be generated by collecting the gases from landfill and from the organic part of municipal solid waste, but this is not something that we are expecting a company to have access to deploy on site, of course. And we have now reached the final technology that we are going to address in this webinar, which is green hydrogen. First, let's understand what is green hydrogen. So there's there's a color system to classify hydrogen. The colors that are attributed to each type of hydrogen depend on the production process. We have two kinds of hydrogen that are considered clean energy. There's blue hydrogen that uses that has a CO2 emission associated, but is coupled with a capture and storage system of carbon. So it is considered clean. And we have hydrogen, the renewable type of hydrogen. This type of hydrogen is produced through electrolysis, which is an electrochemical process that consists on the separation of water into hydrogen and oxygen by using an electrical current. What makes green hydrogen green is the fact that that electrical current comes from electricity generated from renewable sources. Otherwise, it cannot be considered green hydrogen. Green hydrogen can be used for heat production. Specifically, it is seen as a possible strategic fuel to decarbonize heat processes that are difficult to decarbonize or to electrify. It can also be used as energy storage. And this is one of the most important applications that we expect green hydrogen to have in the future, because it can be used to because it can use what otherwise will be curtailed energy from renewable energy systems to generate hydrogen, and that hydrogen can be easily stored and then be used to produce electricity or heat again. A green hydrogen production plant is composed by these groups of components. We have the electrolyzer stack, we have the compression system. The plant also requires a space for storage of hydrogen, and it is also necessary an auxiliary infrastructure. That auxiliary infrastructure is composed by a water treatment system, a power treatment system, and a hydrogen purification system. The water treatment system is required because hydrogen plants require high quality or ultra pure water for green hydrogen generation. This treatment plant constitutes a relatively minor part of the total capex, and poor quality of water can result in higher operation costs because it can provoke corrosion in the electrolyzer cells, reduce the plant efficiency, and impact hydrogen purity. So it's very important to have this unit in the auxiliary infrastructure. Power treatment system is a set of components that are in charge of converting the power that is going to be used into the electrolysis for it to have the necessary characteristics for the process. And hydrogen purification system is a system that comes after the hydrogen production that allows to purify the hydrogen that is produced. The purification, the rate of purification of hydrogen depends on the application of that hydrogen. And I would like to close this part by talking about the two main types of electrolyzers that exist nowadays. The two most used are PEM and alkaline. The first stands for proton exchange membrane. And these are the two most mature types of electrolyzer technology. It shall be said that the first one has more, is the ideal option for pairing with renewable energy applications because it has a much higher flexibility than the ALK system. So it is able to respond faster to load changes which is something that happens when we have a renewable energy system powering the hydrogen plant. So now that we have finished the overview of renewable energy technologies, I am going to tell a little bit about our renewable energy system feasibility assessment. As you have seen, there is a wide number of technologies available that companies can implement to reduce their energy purchase from the grid, or to reduce their environmental impact associated with energy usage. However, the difficulty or the challenge is on finding the best solution or the best combination of solutions. What we do in this service is to try to understand the reality of each company, because there is not one single solution or a combination of solutions that works for everyone. So it is very important to understand what are the characteristics of a business where we want to deploy renewable energy systems. So we first try to understand what are the resources that are available in the location of the site, what characterizes the premises of the company, how is the energy demand profile, what is the available capital to invest, and what is the goal, because it's not the solution, the most suitable solution in terms of renewable energy technology may not be the same if the goal is to fully decarbonize an industrial activity, or if the goal is to find a solution that grants the best economical return. So within this service, we analyze based on the first situational assessment. We identify the technologies that are worth looking into, and for each type of technology and combination of technologies, we run a series of feasibility assessments, and we calculate these indicators. Indicators such as the energy production of that results from installing one or another type of technology, what is the energy that can be self-consumed, and what energy is surplus energy. We also generate economic indicators such as the initial investment, OPEX, return of investment, and so on, and the environmental indicators such as the emission savings of a possible deployment. With the set of tools that we have, we conduct this analysis for each technology alone and combined. With that, we generate the matrix of results, and after analyzing and interpreting those results, we can then identify what is the best solution according with the company's goals. And I'm going to take this opportunity to make an announcement. We are about to release a document that we have been calling the Green Book. The Green Book is a complete document that brings guidelines for each renewable technology type, namely for solar PV, wind, battery energy storage systems, green hydrogen, heat pumps, geothermal, combined heat and power, biomass, process heat that includes technologies to recover waste process heat. And we also have a chapter dedicated to demand-side strategies and to aspects to have into account related with grid connection. So keep an eye on our communication channels because it will be released soon. And with that, I will pass the floor to Gary.
Great stuff, Diana. Fair play to you. There was a lot in that. Fair play to you for getting through all that. We have got a number of questions that have come in. So are there risks, for example, safety or fire concerns associated with BESS?
Yes, there are some fire concerns to have when installing a battery energy storage system. Although those concerns should be addressed by the company that is designing the system, and they have also to be taken into account by the providers of the battery energy storage system.
Very good. And biomass is considered renewable, but how is it really in terms of sustainability, environmental? Doesn't combustion of biomass products release a lot of gases into the atmosphere?
Well, it does. That is true. It does. So there are several layers to this answer. So first of all, it is important to understand that the world has the same way that we have a water cycle in nature. Nature also has a CO2 cycle. And within those CO2 cycle, what happens is that vegetation basically dies and emits CO2 into the atmosphere, but other vegetation, while they are living, absorbs, all types of vegetation captures CO2. So it is true that when we burn biomass, CO2, that CO2 that was captured during the lifetime of biomass will then be released to the atmosphere. And that is the reason why we consider that its impact in terms of CO2 emissions is neutral, because it is emitted, but it was already captured by the same type of biomass. And that is also a reason why the source of the biomass is important for environmental impacts, because to make sure that the CO2 cycle is not disrupted, we have to make sure that the biomass that is being used for energy ends is being replenished at the same rate.
Perfect. Thank you for that. Another question here. You mentioned that batteries can be used for arbitrage. What does that mean?
So arbitrage is the service in which a battery energy storage system is applied and absorbs electricity from the grid during times of the day in which electricity is cheaper, and then release that energy to the site at times when electricity is more expensive. So it doesn't really help the site to consume less electricity, but it helps to reduce the costs of electricity usage.
Very good. Another one here from Vincent. Are there green hydrogen systems in operation in Ireland, and how efficient are they?
There are. There's not a lot of them, but there are a few. One of the problems with scaling green hydrogen systems is precisely the efficiency of the system. There's still some way to go in terms of development of the electrolyzer technology to make the system more efficient. Now, having said that, the economical feasibility of installing a hydrogen production plant to be used then on site really depends on each case. And we would have to look case by case to know if it would be worth the investment or not.
Gotcha. Okay, another one here, and this was asked before you explained a bit about the RES, but it said, please explain what the IMR Renewable Energy Assessment involves and how much does it cost?
Well, we make we calculate the costs depending on each case. Well, it consists on a full assessment of the technologies that I explained. As said before, we first have a few conversations with the company. We try to understand what are their goals. We send them a questionnaire also to understand the characteristics of their sites and to try to understand what kind of technologies make sense to assess for their particular case. Once we determine what are the type of technologies that can make sense on those settings, we run a series of calculations that involve several scenarios for several types of technologies as standalone systems and combined. so that we can have a very comprehensive set of results, and so that we can identify with the indicators calculated what is the best solution. And what is the best solution means what is the best technology or group of technologies, and what is the best size for each of them for the site.
Perfect. I think we have time for one more. There's a couple more, and anyone who's asked a question, we will get back to you via email if we don't get time to answer them right now. But there's another one here. Can you circulate a copy of this presentation to attendees, please, as there's a lot of information in this to understand? Yes, this was recorded, and when we get it edited, we will send it out to everyone who registered. We have other questions there, so we will get back to the rest of you via email. But for now, thank you very much, Diana, for that. That was excellent.